Hi, hello, still me. Still great, I guess. With a stash still, but same shirt, the same cat, right, Coco? For this video, it's gonna be the combination of two concepts because somehow, some way, they're both related and at the same time, they follow the same style of solving. So why not just combine them in one video? So for this one, we're gonna multiply and divide rational algebraic expressions, right? So let's just jump right into it. Yeah, jump. Now that we're done with simplifying RAEs, let us continue and performing operations on RAEs. No, we're not gonna operate the crewmates that we have here. No, we're gonna operate on or multiply and divide rational algebraic expressions. So for the last thing that we did, we had something with the wires, and now somehow, some way, someone is trying to sabotage us. So we'll go back at it. So now we have the following: multiply or divide the given fractions. Some of you guys might have known already how to deal with this, some don't, and it's important to remember again that there are different ways of solving this. What I'm going to show you again is maximizing the concept of factoring or simplifying by GCF first. So you have 6 over 18 times 3 over 5. What you can do here is you simplify it. 6 over 18 can be simplified as 1 over 3. The GCF being 6. So this will be 1, this will be 3. Now, how do you multiply it? There are two ways. You can simplify then multiply, or multiply then simplify. And this is an important rule that will play a huge role later. Always remember that when simplifying or multiplying fractions or RAEs, you can simplify or cancel out if the relationship is numerator-denominator. As you can see here, the 3 is in the denominator and the 3 here is in the numerator. We can actually cancel that out. This will be 1, this will be 1. That's why the answer is none other than 1 over 5. And we'll try this one more time. Let's simplify first. 4 over 24. The GCF is 4. This will be 1. This will be 6. So this is 1 over 6 times the quantity. 6 divided by 2. This will be 3. This will be 4. So 1 over 6 times 3 over 4. And as I said earlier, you can simplify something if they have a relationship that is numerator, denominator, and so on and so forth. Now, if you look at this, 6 and 3 can be simplified because 6 is in the denominator position, 3 is in the numerator position, and they have a common factor. Divide both by 3, this will be 2, this will be 1. 1 times 1 is 1, 2 times 4 is 8. So it's 1 over 8, and as you can notice, we are correct with that. The third one, basically, it's just something to tell you guys that dividing something by itself, the answer will always be 1. But let us focus with the last example. What do we do when we are given with dividing or division of fractions, to say the least? So basically, it's important to remember, it was given to me by my students from the past. I think their teacher introduced it to them. It's called KCF, basically keep, change, flip. So what do we mean by this when we're dividing fractions? So we keep the dividend as it is, or the first one as it is, 14 over 49, and then we change what? Not ourselves, but the operation. So instead of division, it will now be multiplication. And what do we mean by flip? Basically, we get the reciprocal of the divisor. To get the reciprocal of the divisor, you make the denominator the numerator and the numerator as the denominator. And that's it, basically. So we can simplify this. 14 can be 2. This could be 7. The GCF they have is 7. 42 and 21, they can be simplified. This is 2. This is 1. The GCF is 21. 2 times 2 is 4. 7 times 1 is 7. So this is your final answer. So that's how it looks like. So again, there are different ways of solving this, but always remember the rule for division compared to multiplication of fractions. In division, you have the KCF first, not Kentucky Chicken Fried, but keep, change, flip. We keep the dividend as it is, change the operation division and make it multiplication, and then we flip our given divisor. We get its reciprocal. So to continue, let us now have some examples. So that's basically what it implies. Now let's go to our first destination. We have a raised to 5 over 10. and we're trying to multiply it to 5 over 8 raised to 3. If you can see the guide questions right here, can there be simplification done for this given? Well, we can. For as I said earlier, the rule is if the relationship is numerator denominator, you can simplify them. Okay? So for example, you have a raised to 5 and a raised to 3. So this is in the numerator, this is in the denominator. You can simplify that. So what's the GCF of these two variables? It's a raised to 3, since that's the lowest exponent. So a raised to 5 divided by a raised to 3 is a raised to 2. A raised to 3 divided by itself is equal to 1. Similarly, 5 and 10 has the similar relationship. 10 is the denominator, 5 is the numerator. The GCF is 5, this will be 2, and this will be 1. So a squared times 1, that's equal to a squared, and then 2 times 1, that is equal to 2. So this is your final answer. So you might have a case wherein you want to multiply first. This is something that I can suggest if you're still struggling with it, but it's much better to do the simplifying immediately, especially when you're dealing with binomials and trinomials when you factor them. But here you can do that. So 5 times a raised to 5 is 5a raised to 5. 10 times a cubed is 10a raised to 3. So it becomes one fraction that you still have to simplify, and that will have the same answer. So you'll have a squared all over 2. So you may have that. You can multiply, then simplify, or simplify, then multiply, depending on how you would like to do it. Okay? So that's it. Let's have another one. Similarly, this one again, if you wish to multiply first before simplifying, it's okay, but you can simplify first, then multiply. So here you can start with 2 and the 8. 2 divided by 2 is 1. 8 divided by 2 is 4. A squared and a raised to 4, the GCF is a raised to 2. This will be 1, and this will be a raised to 2. 15 and 5, the GCF is 5. This will be 1, this will be 3. C cubed and C, the GCF is C. This will be 1, this will be C squared. So 1 times 1 times 3 times 1 is equal to 3. 1 times C squared times 4A squared is equal to 4A squared C squared. Always remember to put the variables in alphabetical order so that you will not have a problem. So that's it for multiplying or multiplication of RAEs. Let's have another one. 30b squared all over 6c, 4c squared all over 15b raised to 4. There are different kinds of pairing that you can do here. It depends on you. But for me, I'll start with 30 and 15. 30 divided by 15, that will be equal to 2. 15 divided by 15, that will be equal to 1. I can still simplify 6 and 4 using the GCF 2. This will be 3. This will be 2. What else can we simplify? The b's. The GCF is b squared. This will be 1. This will be b squared. For c and c squared, the lower exponent is c. So divide both by c. This will be 1. And this will be c. So as you can see here, we have left 2 times 1 times 2 times c. The answer is 4c. Below we have 3 times 1 times 1 times b squared. That's 3b squared. So that is your final answer. That's it. And I repeat, you can have different combinations here of simplifying. You can simplify 30 and 6 first, and still we will arrive with the same answer. So it depends on you and how you would like to pair them. As long as the relationship is numerator-denominator, you're not going to have a problem on that. Let's continue with some more examples. Here we go. Let's say we have this. Now we have to deal with this step by step. We have to factor out things that we need to factor out. 3d minus 12 is factorable. So we factor that first. There's a GCF of 3. And this will now become d minus 4. So how do we get d minus 4 there? 3d divided by 3 is d. Negative 12 divided by 3 is negative 4. So we factor it out. Similarly, this will be 4 times the quantity d minus 4. And now we can find things to simplify. We can simplify the d minus 4s. We can also simplify the 3s here. What else can we simplify? The c's. This will be c. This will be 1. The 4 can still be simplified. This will be 1. This will be 3. So what's left above is none other than 1. And what's left below is 3c. So you can continue canceling out or simplifying as long as there's something that you can simplify. That's the only rule in this one. Once you cannot simplify anything anymore, then that's the final answer. 1 over 3c for this one. Let's have some more. Let's go. Now we're dealing with a perfect square trinomial and another one through factoring by GCF. So this one is a perfect square trinomial. H squared, so h times h. Positive 9, but the middle term is negative 6, so negative 3 times negative 3 instead. Okay, what's next? GCF of h squared minus 2h is h, and this would be h minus 2. As you can see here, we can simplify the h minus 2's, and we can simplify the h minus 3's. So what's left here as the final answer is h minus 3 all over h. Always remember again, you cannot cancel out the h's because the numerator is a binomial and the denominator is a monomial. The numerator is a binomial, denominator is a monomial. You cannot cancel out anything anymore. So this is your final answer. So basically, multiplying RAEs is simplifying and then multiplying, or multiplying then simplifying. Ganun lang siya. That's why simplifying fractions is an important skill, similar with multiplying and dividing fractions. So let's proceed to another example. Now we have again 3m plus 6. This is factorable. Find the GCF, which is 3. This will be m plus 2. M squared plus 3m plus 2, an example of a general trinomial. So let's identify factors of 2 that if you multiply it's equal to 2, but if you add it, it's equal to 3. So that's none other than positive 2 and positive 1. So we can simplify the m plus 2's. Start with that. This will be 1, this will be 1, 21 and 3, this will be 1, this will be 7. Cancel out the 7's. This will be 1, this will be 1. The m's, this will be 1, this will be m. So above, we only have m times the quantity m plus 1. So let's have that. What else do we have? Oh, we have the 3m plus 6 canceled out, basically similar with 7m. So all over 1. And when this happens, your final answer could be a whole term lang. And it's the quantity m times the quantity m plus 1. That's how it works. And remember this always, any number or any term or any polynomial over 1 will always be equal to itself. So no need to write the denominator when it's 1. So let's continue with more examples. I think this time we're now going to divide. Yes, we're going to divide now. And here again, remember the process of dividing fractions. It's similar with dividing RAEs. So we keep 12b squared as it is. 18c squared as it is. Change the operation to multiplication. But first, make sure to flip your divisor. So this will be 3c all over 4b squared. And in this case, we can now start simplifying. 12b squared and 4b squared have a common factor, which is 4b squared. And this will be equal to 3. 18c squared and 3c has a common factor, which is 3c. This will be 1. And this will be 6c. And you can still simplify 3 and 6. So this will be 1 and this will be 2. So your final answer here is none other than 1/2. So that's how it works. So again, the difference between dividing and multiplying is basically, let's put it this way. Dividing RAEs is multiplying RAEs with an extra step. The extra step is the KCF. Keep the dividend as it is. Change the operation division to multiplication. And then flip your divisor or get its reciprocal. That's it. So let's continue with some more examples. Let's have this now. Again, let's keep our dividend as it is. Change the operation to multiplication. And flip your divisor. So 24 all over 4a minus 8b. And as you can see, there's still something here we can factor out. This will now become 4 times the quantity a minus 2b. And as you can notice, we can cancel out the a minus 2b's here. 4 and 24 has a common factor. This could be 1 and this could be 6. 6 and 16 still has a common factor. This could be 3 and this could be 8. So your final answer here is none other than 3 over 8. So that's how it works. It's a little fast, but always remember this one. It's similar to simplifying. It's just that you have to remember that now you're dealing with two RAEs, and you can simplify or cancel things when their relationship is numerator denominator, and it's monomial by a monomial, binomial by a binomial, and so on and so forth. So let's have another example. This time around, let's go ahead. Okay, so let's just copy the first, our dividend, 8c cubed all over 6 times the quantity c plus d. And then let's flip this one right here, 3c plus 3d all over 2c squared. And we can factor this out as 3 times the quantity c plus d. And we can cancel out the c plus d's. We can simplify the 3 and the 6. This will be 1 and this will be 2. 8c cubed and 2c squared. The GCF is 2c squared. This will be 1. And this will be 4c. And as you can notice, we can still simplify the 4 and the 2. This will be 1. This will be 2. The final answer is 2 times c. That's 2c all over 1. Or simply 2c. That's how it works. Do we still have some more? I guess so. Let's see. Okay, now we have your numerator as a difference of two squares, so we can factor that out as m squared plus n squared, and we multiply that to m squared minus n squared because that's the difference of two squares. This one can be simplified given that the GCF is 6 times the quantity m minus n. Similarly, this one, you should flip it first, so 6 all over m squared plus n squared. So the beauty of this example is that there's a continuous process that we can still do. But in the meantime, let us simplify what we can simplify first. So the m squared plus n squareds can be simplified. Same case with the 6 and the 6 here. So the final answer here, if you look at it, is m squared minus n squared all over m minus n. But the beauty of this example, looking at it now, it's still not the final answer. Because if you look at the numerator, that is a special product again. And it's an example of a difference of two squares. So we can still factor it out. So let's continue, factor this one out. This will be m plus n times the quantity m minus n all over m minus n. And as you can see, there's still something that we can simplify, the m minus n's. And the final answer is m plus n all over 1, or simply m plus n. So that's how it works. Again, sometimes you will see that there's still something that can be simplified once you're done solving. And it's still okay. Just continue with it. Again, as long as there's something that you can simplify, simplify it. No problem with that. Do we still have an example? Yep, we're now on the last one. We have a difference of two squares in our m squared minus 4. So let's factor that out. This will be m plus 2 times the quantity m minus 2. Our denominator is a general trinomial. Think of factors of 2 that if you add it's equal to negative 3. That's basically m minus 2 and m minus 1. Always remember, class, if your last term is positive, the sign of the two factors depends on the middle term. Okay? So since your middle term is negative, so both should be negative. So let's flip this one right here, m minus 1 all over m. We can simplify the m minus 1's. We can simplify the m minus 2's. And your final answer is m plus 2 all over m. Again, you cannot simplify this because the numerator is a binomial, the denominator is a monomial. And I think this is our last example. So this is a combination of a lot of general trinomials. So let's do this slower this time around. Class, if you see something like this, do not panic. Always remember first that, again, factor 1 by 1. So for v squared plus v minus 12, you're being asked to think of factors of negative 12 that when you add it, it's equal to 1. So since the middle term is positive, that implies that the higher number is positive, which is 4. 4 times negative 3 is negative 12. 4 plus negative 3 is equal to 1. Similarly, now the difference between the denominator and the numerator is that now, I think there's a number that you can see, it's equal to 3. So, it's still positive, so we'll have v plus 4 and v minus 1. Why? Negative 1 times 4 is negative 4. 4 plus negative 1 is positive 3. And Here, we can skip this one right here in terms of positioning, or we may solve this one by one still. So we can have here v minus 3 and v plus 2. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. This one right here is v minus 3 times v minus 2. Why are they both negative? Because negative 3 times negative 2, positive 6. Negative 3 plus negative 2, negative 5. So since we're going to flip it, v minus 3 and v minus 2 are above. And the denominator will have v minus 3 and v plus 2. We can simplify the v plus 4's here. We can simplify the v minus 3 and the v minus 3 here. And what else can we simplify here? Oh, I'm so sorry. There's a mistake with this one. It should be v minus 6 and v... No. Correct pala ako. V minus 3. Oh, sorry. I panicked a little. No, it's correct. Sorry. Never mind. It's correct. I just got confused a little bit. I was like, is there something wrong with the solution? But no. So, is that all we can simplify? Yes. So, v minus 3, v minus 2, all over, v minus 1, all over v plus 2. I have to double check lang for a second. Yeah. I think we're all good. Yep, we're all good. Small mistake. I'm so sorry. So here, again, do not multiply it. Just let it be what it is already. Because if you keep multiplying it, you're going to go back to factoring. So this should be your final answer. Okay? And that basically ends our discussion of multiplying and dividing RAEs. And that ends our video lesson for today. Hope you guys learned a lot. And I think Coco learned a lot, right? Did you learn a lot, Coco? So in case you want to check out some of the lessons, especially now that we're simplifying, multiplying, dividing RAE, it's important to go back to some factoring lessons. Make sure to check out the videos that were prepared last time so that you will be refreshed with the topic. And that's it for me. And in case you don't see me, good morning, good afternoon, good evening, and good night. Bye-bye. Peace out. Respect.